Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Salam.
So today our group has been given a task and our case study is about the implementation of ANN, artificial neural network, on electrical power industry. Next. So here are our group members. Here are the proposing an application of ANN in specified target. So our specified target is electrical. Okay, machine learning. Machine learning is algorithm that known as artificial neural network, or the short form is ANN, are modeled after the structure and operation of human brain. They are frequently employed in projects like grouping, regression, and classification. So another information, ANN also can be used in a variety of ways in the agriculture sector to promote sustainable development in a number of ways. Okay, the next point, the potential of the application of ANN in the electrical power industry to achieve sustainable development is in the area of demand forecasting. Accurate demand forecasting play a crucial role in optimizing energy production and distribution, reducing waste, and promoting renewable energy integration. So ANN can be used to analyze historical data and predict future electricity demand pattern, enabling power companies to make informed decisions and plan their operation effectively. Next. So here are 5 types of electricity sustainable. Electric power sustainable development. So the first one is optimal load management. The second one, grid stability and efficiency. The third one, renewable energy integration. The fourth one, infrastructure planning. And the last one, energy efficiency initiative. So for optimal load management, it's accurately predicting electricity demand. Power companies can optimize load management strategies. So the second one, for grid stability of efficiency, ANN can be assist in maintaining the stability and efficiency of the power grid. Next, renewable energy integration. ANN also can aid the integration of renewable energy sources into the power grid. The next one, infrastructure planning. It's been used to accurate demand forecasting through ANN enables power companies to plan infrastructure developments more efficiently. And the last one, energy efficient initiative. ANN also can support energy efficiency initiative by identifying patterns and correlation in energy consumption data. So for the summary, we know ANN are demanded forecasting, and it help electric power companies to achieve sustainable development goal by optimizing load management, enhancing grid stability and efficiency, promoting renewable energy integration, facilitating infrastructure planning, and supporting energy efficiency initiative. This application enable to power industry to operate more sustainably, reduce environmental impact, and transition towards a greener energy future. So that's all from me. I give it to the next presenter.
Thank you for your presentation. Now I will present about benefit of implementing the ANN in the electrical industry. The first one is accurate demand forecasting. ANN can provide highly accurate prediction of electricity demand by analyzing historical data and identifying complex patterns. This allows electrical power companies to optimize their resource allocation plan maintenance activity, and make informed decision about energy generation and distribution. The second one is renewable energy integration. ANN can facilitate the effective integration of renewable energy sources such as solar and wind into the power grid by forecasting electricity demand patterns that align with renewable energy generation profiles. ANN can help power companies balance the intermittent nature of renewable energy source and ensure all reliable and stable power supply. The third one is reduce energy waste. By accurately predicting demand, ANN can help prevent overgeneration of electricity, which leads to waste by aligning energy generation with actual demand. Power companies can reduce energy loss and optimize the overall efficiency of the power system. Next slide, please. Next slide. The fourth one is cost saving and improve financial performance. Optimize resource allocation, reduce energy waste, and improve grid stability. All contribute to cost saving for electric power companies. Accurate demand forecasting help prevent underutilization or overutilization of resource, leading to improved financial performance. And the last one is enhance customer satisfaction. Relevant analytical supply is crucial for customer satisfaction, and ANN can help power companies anticipate a demand fluctuation, reduce power outage, and ensure consistent energy supply, resulting in improved customer experience and satisfaction. I will pass to Naufal to present his part, which is to recommend suitable data to train this ANN.
Okay, thank you, Aizat. So this is our training data requirement, which is the data set that we can use to train our ANN, which is the artificial neural network. So based on this figure, it shows the energy consumption for the household with the highest matching accuracy within the test set of the small residential area. So this graph conclude between the 25 household test data set in 1 year of consumption. So the duration of this data, which is the between October 2017 until September 2018, and we recorded the data every hour in the time period. So as we can see, the input for this data, which is the time of day and also the duration, the duration of year, the duration of month. Also the output for this data, which is the consumption that we use in every time. So in this graph, we can see that average data, which is the the blue color, between 0.4 until 0.8 kilowatt per hour, and a certain day between 12 AM until 6 PM, and also at the night between 8 PM until 12 AM. The data shows between 0.0 until 0.2, which is the purple color. So in this data, we can see that most households use the consumption, which is the electricity, between average between 0.4 until 1.0 kilowatt per hour for the consumption data of the household, matching the accuracy from the 25 household test data set. So this data set we can use to predict the next consumption that the household will use for the next time. So that's all from me, and I pass to the next presenter.
What is an ANN architecture? ANN architecture refers to the structure and organization of an artificial neural network. It defines the arrangement of artificial neuron, also known as nodes or units, and the connection between them. The architecture determines how information flow through the network and how it processed. The artificial architecture of an ANN typically consists of multiple layers, including input layer, one or more hidden layer, and an output layer. The number of layers and the number of nodes in each layer can be varied depending on the specific problem and requirement. Next. So then, what is an optimizer? It is a crucial component of training ANNs. The optimizer is responsible for updating the weight and bias of the network based on the error or loss between the predicted output and desired output. Okay. So, next. So, for the recommendation on the ANN architecture and optimizer, I recommend on using the convolutional neural network CNN architecture because first, CNN are particularly effective for image and video processing tasks. They have demonstrated exceptional performance in tasks such as image recognition, object detection, image segmentation. The basic structure of CNN consists of convolution layer, pooling layer, and fully connected layer. Convolution layer learns local pattern and features from the input image, and pooling layers sample the learned feature. And fully connected layers make prediction based on the extracted features. Next, the Adam optimizer, because it is a popular optimizer that has shown good performance in training deep neural network. It's combined the advantage of two other optimizers, that is ADAGRAD, which adapt the learning rate based on the individual parameter, and RMS prop, which maintains a moving average of the squared gradient. Adam adjusts the learning rate of each parameter individually and incorporates both first and second moment of the gradient to update the model weight effectively. It provides efficient convergence and has been widely used in various deep learning applications. Okay, I pass to next presenter.
Okay. For loss criterion, we use mean absolute percentage error, which is MAPE. Why we use it? It's because power companies need accurate forecasting to manage renewable energy integration. MAPE measures percentage deviation, making it easier to interpret. MAPE help companies understand error magnitudes and make informed decision based on forecasting deviation. Next. Okay. This is formula for MAPE. Which is A is for actual value, F is forecasting value, and N is total number of observation. So MAPE range from 0% to positive infinity. Lower MAPE values indicate better accuracy, with 0% representing a perfect prediction. Higher MAPE values suggest larger average percentage deviation between predicted and actual values. By using MAPE as a loss criterion for ANN model, power companies can access the average percentage error in their power forecasting. This aligns with their goals of achieving reliable and accurate prediction. MAPE provides an easy-to-understand measure for evaluating the model's performance and can drive improvements in power forecasting accuracy. This contributes to more efficient grid management and sustainable energy practice. So that's all from us. Thank you.